Okay, so on this first page, we've already kind of learned how to do some of this on the calculator. We haven't done all this yet, though. So I'm going to go through, if you brought a calculator, just get your calculator out, and I want to make sure you're going to have to use your calculator in this section. So a couple of things I want to remind you of doing. First of all, always pay attention to the mode you're in. Okay, so remember, if you got your mode button, that allows you to go from radians to degrees. Okay, so the first problems are all going to be in degree mode. So I'm going to take my calculator and I'm going to put this in degree mode. And you just go highlight the degree and press enter unless you're already there. Okay, and then we're just going to put these in. So there's different ways you can do this. So you can write the answer. You can write down the keystrokes if you need to, but it's the first one you're going to do, sine of 67. You don't have to put the degree symbol because the calculator knows that's degrees because you're in degree mode. Okay, so if I do that, I'm just going to round to I'm going to just do all of these to 4 decimals. So that would be 0.9205. Okay, I was a college student taking trigonometry in 1982. We did have calculators, but before, like in the 70s, you know what trig students had to do? They had to go to the back of the book and look these up in a table. So even like this second problem with the tangent, you had to go to the back of the book. There's this table that was several pages. You just looked them up. Okay, in the modern world, we do the calculator. And the calculator started coming out with this in the very late 70s. I was kind of in the time when you could do that, but I can tell my teacher was kind of an old guy, so he taught us how to look it up in a table. Okay, let's do the next one. Okay, now there's more than one way we can do this. I've already shown you how to do this. Remember your angle button, if you go second apps, that will tell you where all the symbols are. So if you want to put those symbols in, you may. I just always bypass this. This is what I do. I'm in degree mode. I'm just going to convert this to a decimal part. So the 23 minutes, what do you do with that? Over 60. Okay, how about the 43 seconds? What do you do with that? 3,600. Okay, we learned that in the first section. That's the way I do that. I just find it easier to just put it in my calculator. But if you want to go put in those symbols, you can do that. It's going to give you same answer anyway. Okay, so let's see. I'm going to round that to 4 decimals, so that's 0.5406. The 5 would have to go up to 6 because the number after that's a 9. Okay, so I already showed you how to do this. I haven't really shown you yet how to do a secant or a cosecant. And you don't have a secant button or a cosecant or a cotangent, but you don't have to have one. The reason is because you have an identity. So in this problem, you need to know that the secant of 45 is 1 over the cosine of 45. See, that's the identity, and you're going to use this all the time, okay? So if you want to put the secant in, you want to go 1 divided by cosine of 45, okay? And that's the only way you can really do this, is since you don't have a secant button, is you just do that, okay? And then round that off, and that would give 1.4142. Okay, a little bit later in the class, you're going to learn that it's the square root of 2, and the square root of 2 is that number. Okay, we're not there yet, but we're going to learn that tonight. Okay, if you're doing a cosecant, we have the identity that says the cosecant of 0 would be 1 over what? Sine. Okay, so you need to know that, use that identity in this case. So what you want to do on this one is just go 1 divided by sine of 0. Okay, and you get an error sometimes. Okay, that's going to happen. Now, you don't say error. The answer to the problem is not that it's an error. It's that it's undefined. And as we kind of learn a little bit more about trig as we go, you'll begin to see why these things sometimes are undefined. So if that happens, that's supposed to happen on that problem. Okay, that's the idea. Okay, all right, so if you put in the secant and cosecant, that's the way you got to go about doing that. Okay, the next ones that you want to do is, well, you're in radians. Okay, you always assume your angle's in radians unless it has a degree symbol. So what we want to do is go to your mode button, and I have to clear that off first. So I'm going to go to my mode button. Now I'm just going to change to radians. And this is something you're going to do in the class a lot, is go back and forth between different modes. Okay, now if I put the cosine in, I'm now in radian mode, so it's expecting a radian angle, so I just go cosine of pi over 3. And when you do this, put the pi key, because my math lab, you're going to run into some rounding issues a little bit from time to time. If you just get all the decimals and round at the end, you should theoretically be okay. I say in theory, that is. Okay, so that's 0.5, like that. Okay. The next one, you would do the sine of negative 2.3. Okay, you got to do that, and we'll round that off, so you'll get some sort of an answer on that. There's times when you'll get negative answers, so that's negative 0.7457, like that then. Okay? Okay, now you don't have a cotangent button, so what do? You do 1 over tangent. Okay, you got to know that identity. So the idea is the cotangent of 4 is equal to 1 over the tangent. Okay, so that's how you're going to have to do a cotangent in your calculators. You got to put it in like that. So I'm going to go 1 divided by tangent of 4. And then I can round the answer off like that. Usually the calculator doesn't mind if you don't put in that right parenthesis. So that's 0.8637, like that. Okay? All right, everybody got that okay? Okay? That's pretty simple. You're going to do this in this section because we're going to start doing application problems with triangles and stuff, and you're going to have to use your calculator. Okay, so you got to know how to do that.
Is it because I have a different type of calculator that I'm getting completely different answers with this sine?
That's a totally different calculator. Do you see on there how to change from radians to degrees?
No.
I may have to, if you got time after class, let me look at it. Because you can use a calculator like that. I'm always going to demonstrate with a TI, but that's a scientific calculator. I'm pretty sure it'll do it. And it'll just take me a few minutes. Anybody else have a different calculator that they have a question on? What have you got, TI-83?
How do you select degrees? Because like I'm pressing enter and it's just not.
Okay, okay. What you do, if you're changing the mode, you got to use your cursor keys to highlight.
Oh, okay.
And then when it's blinking, that's when you press enter to change it. You got to be sure that you press enter after it's blinking on the right thing.
And then just clear it.
Yeah, that's it. And then you're ready to go. Okay. Yeah, you can always go, see this button that says quit? That's another way. If you go second mode, it'll just take you back there. Like that. Quit means get out of whatever screen you're in and back to the home screen. Okay. Okay, next thing we're going to do is, here's another thing. This is a section that has all kinds of things you got to memorize. So when I give you a quiz next week, one of the things I do is I just give you a 30-60 triangle and you fill in the sides. It's not that hard to remember, but you're going to utilize this all the time in trig, so you got to know how this triangle goes. Okay, so a couple of things I'm going to show you is how to make sense of this. Okay, because I'm going to take this triangle and I'm going to twist it around a little bit. So this is kind of in a reduced form like this. And the way I try to help students remember this, let's see, there's a statement I used to hear that says, easy as 1, 2, 3. I've heard that statement before. Well, this triangle is easy as 1, 2 square root of 3. Now what you do is you put the numbers in logical places. Don't just blindly memorize those numbers because you'll forget it. Here's what you want to do. This 1 is the smallest side. Okay, and let me clear that off. I didn't write that very good. This is just kind of a thought process that you want to learn how to go through. You have a 2. 2 is the biggest number. Okay, and then the square root of 3. If you took the square root of 3 on your calculator, you would get 1.7. So it's kind of the side that's in the middle. And it's very logical if you do this. So if the smallest side is 1, does it make sense to you that that smallest side would go opposite the smallest angle? Okay. 2 is the biggest side, so that's always the hypotenuse. You already know that. So that goes opposite the biggest angle. So the way you're going to do this is just remember the 1, 2 square root of 3. In this problem, what's going to go with the 30? The smallest, 1. What's going to go with the 60? The one in the middle, square root of 3. What's going to go past the 90? The 2. Okay, that's why you want to do that. Does that make sense? Reason it out, okay? Understand it, because you need to be able to build that as you go. So this would be 1, 2 square root of 3 like that, okay? Now what I want to do is I want to show you where this comes from, because how a mathematician figured this out. We've known about this for probably about 2,000 years roughly. That's kind of how we started discovering square roots that are irrational, was with working with right triangles like this. So let me show you this derivation. This is a good thing to know how to do. So what I would like you to do is draw a triangle like this. And what we're going to do on this, let's see, I think I'm going to do it this way. I'm going to have you just call that 2, 2, and 2. And I'm just going to show you one way to derive this. The reason I'm doing 2 is because I'm kind of matching up that slanted side with that hypotenuse. Okay? So here's how we can figure this out. Okay, if you have an equilateral triangle, all sides are equal. What do you think all the angles are if the triangles all have the same side? 60. 60 is logical because 60, 60, and 60 all add to 180. Okay, so that's kind of a geometric theorem we know. Okay, then what we're going to do is we're going to go straight down to the x-axis, or not the x-axis, straight down to the base of the triangle like this. Now there's some geometry that sometimes students have learned in high school, sometimes they haven't. But this is pretty logical. Is it logical to you that that would be a 1? I mean, it seems like it would be. There's a geometric theorem that says on an equilateral triangle, if you do an altitude, it will bisect that side. Okay, that's the kind of stuff that you learn a lot in high school geometry. So what we're going to have now is we're going to have this side is 2, this side is 1 now. Okay? And then we've already got the angle. The other thing that hopefully makes sense to you is, does it make sense that angle would probably be 30? Okay, that just bisects that. There's a geometric theorem that tells you that too. Okay, so that would be a 30-degree angle. And then, if you know two sides of a right triangle, you just use the Pythagorean theorem to find the other one. So if you did c squared is a squared plus b squared, see, we know the hypotenuse. So that's 2. The 1 is a leg, so that can be a or b. So we just plug that in. And if you work out the details, you're going to get square root of 3. Okay, so this is going to give 4 equals 1 plus b squared. You can subtract 1 from both sides. Okay, then you would get 3 is equal to b squared. So then you would get square root of 3. That's where it comes from. Okay, that's how we figured that out. You have to know in order to come up with those sides, you would have to know a couple of geometric theorems, and you'd have to know the Pythagorean theorem. Okay? But mainly for your purpose, I want you to memorize the triangle because you're going to use a lot. Okay? All right? Just know how to put that 1, 2, 3 in there. And I'll show you why we're doing this. We'll get to that here in just a minute. Okay, on the next page, we have one other triangle that you got to memorize. This is the 45, 45 right triangle, and the sides go 1, 1, square root of 2. Okay? So 45 is kind of a good angle. Now, first of all, does it make sense to you that those two sides, 1 and 1, would be equal? Is that logical? The angles are equal, right? So we have a theorem in geometry that says if you have two equal angles, the side opposites are also going to be equal. And then the square root of 2 came from the Pythagorean theorem. So basically with this one, the 1s go opposite the 45, then you got the hypotenuse of square root of 2 if you do the Pythagorean theorem. Okay, let me show you where this one comes from. So the derivation of this goes like this. Draw a square, and we're going to just, for simplicity, make every side 1. Okay, you could make the side anything you wanted to, but I'm just going to use 1 on that. Okay, then what I'm going to do is I'm going to draw a diagonal. Okay, and again, you just got to know some basic geometry. Okay, so does it make sense if this is a 90-degree angle, that would probably just cut that in half and make it 45 and 45? Okay, there is a proven geometric theorem that says that. So you have a 45, 45 right triangle, right? And then how would you find that? That's the hypotenuse. So you would just go c squared equals 1 squared plus 1 squared. That's where you would get the square root of 2 out of that then. So I'm going to finish that up like that. I'll call that c. Then we'd have c squared is a squared plus b squared. So that's c squared equals 1 squared plus 1 squared. So c squared is equal to 1 plus 1 or 2. And then that's where the square root of 2 comes from. Okay? So that's the idea. Okay, it's good to know where stuff comes from. It really, really is. Okay, and the higher you get in math, the more your teachers spend time on proving stuff and deriving, because it's an important part of it. You're getting more technical as you proceed through your education. Okay? Okay, so at a minimum, get those things memorized. Okay, now I'm going to show you why we're learning this. Okay, as we learn trigonometry, what we're doing right now is we're getting ourselves familiar with the definitions. So what I'm going to do is just kind of write these down at the side, and you don't need to write these down. I'm just going to put this more for reference. The sine is opposite over hypotenuse. The cosine is adjacent over hypotenuse. And then the tangent of theta is opposite over adjacent. Okay? SOHCAHTOA, whatever method you want to do. What did I show you last time? Oscar has a hairy old ass. I had a student that gave me that one once. I got to remember the one about the hippie that I read today because it was funny. I can't remember exactly what it was in. Okay, then the cosecant is the h over hypotenuse over opposite. The secant is the reciprocal of the cosine. And then the cotangent is the reciprocal of the tangent. Okay, so we have all that. Okay, now just for reference, I want that up there, but you don't need to write that down if you don't want to. Okay, so what we're going to do is we're going to do the sine of pi over 4. First of all, how do you change pi over 4 to degrees? All we know is triangles right now. What's pi? 180, right? So 180 over 4, if you work that out, it's 45 degrees. So what we're really doing is we're doing the sine of 45 degrees. Okay, and we're going to look at that at the triangle 45, 45 to figure this out. Okay, so what we're going to do is the sine's definition is opposite over hypotenuse. Okay, so just pick one of your 45 degree angles. It doesn't matter which one you look at, you'll get the same answer. So if you look at this triangle, what is the side opposite of that angle? 1. What's the hypotenuse? Square root of 2. So you're going to get 1 over square root of 2, and then you can rationalize that denominator. Okay, that's the idea. So you can get an exact answer on this. So we have 1 over square root of 2. Rationalize the denominator. Okay, students usually don't have much trouble with rationalizing because you're going to do it so much in this class. So that's square root of 2 over 2 like that. That's the answer that I'm looking for. Okay, so we're going to push on with the next one. The next one is the tangent of 45 degrees. So you want to look at your definition. Okay, the definition of the tangent is opposite over adjacent. Okay, and we talked about this in last week's class. So what is the side opposite 45? It's 1. What's adjacent? That. Adjacent means next to it. Okay, it's not the hypotenuse, it's the other side. So it's going to be 1 over 1. So what you would have is that would be 1 over 1, which is equal to 1. So the tangent of 45 is 1. Okay? Now, one thing that you can do on these problems can be checked with your calculator. Like right now, I think my calculator is in degree mode. So if I did the tangent of 45, I would get 1. I'm just showing you where it comes from. If you did the square root of 2 over 2, if you did the sine of 45, you're going to get a bunch of decimals. But if you did the square root of 2 divided by 2, you would get the same thing. So you can check on the calculator. You see what I mean? Okay. Your goal is to be able to do these kind of problems. You don't need a calculator to do this because I'm looking for an exact answer. Calculator doesn't always give you an exact answer. Okay. Okay, next thing would be the secant. Okay, and again, this is just the secant of 45 degrees. The secant's definition is hypotenuse over adjacent. Okay, so we just take a look at the triangle and figure that out. Okay, so what would be hypotenuse of this triangle? Square root of 2, what's adjacent? 1. Okay, that's opposite, adjacent, hypotenuse. So that's going to be square root of 2 over 1, so it's square root of 2. Okay, that's how that goes. Okay, does that make sense to everybody? Okay, this is just an activity that gets you comfortable with definitions. That's mostly what we do in this section. Okay, now what I'm going to do is I'm just going to give you a couple of minutes to do 7, 8, and 9. Now what you want to do on this, you want to look at that. You want to look at the 30-60 triangle, and you want to look at the definitions. Okay, so go ahead and go for that and see what you come up with. And you can compare answers if you want to and see if you're on the right track. You got to use the definitions, and then you got to look at the 30-60 right triangle when you're doing that then, okay? Okay, so as long as you understand what everything is, and the triangle should be a pretty easy thing to do. So if you're doing 30 degrees, you look at that angle. So what's opposite 30? 1. What's the hypotenuse? 2. So what do you get? 1/2. Okay, the answer to that one would be 1/2. That's opposite. Hypotenuse is 2. Okay, that's what I want. I don't want a decimal. I'm just looking for the 1/2, the reduced fraction like that. Okay? Okay. Now if you go to 60 degrees, this is the secant of 60. So what do? You do hypotenuse over adjacent. What do you have? 2 there. What's the adjacent? That one. See, that's opposite, adjacent, hypotenuse. So that's 2 over 1 also. Okay, so or 2 over 1 would give you 2. Okay, like that. Okay, so that's the answer. Okay, and then the last one, what you're doing is you need to know that pi over 6 is 30 degrees because pi is 180. That's 30 degrees. So if you look at the 30-degree angle, a cosecant's hypotenuse over opposite. So what do you have? 2 over 1. Everybody got that? Okay. Well, get comfortable with what those definitions mean when you're doing that. So hypotenuse is 2, opposite's 1, so that's equal to 2. And all these things can be checked on a calculator, every single one of them, so you can make sure that you're doing these right. Okay. Okay. Does anybody have a question about that? Okay. Okay. Get these definitions learned as fast as you can. Now, this next page, what I'm doing, this is partially a little bit of a college algebra review because it has to do with composition of functions, but it also has to do with triangles. So I'm kind of using this as a review. So this is composition of functions. When you see that open circle right there, that's composition of functions. Okay, what this means and what you're supposed to learn in a college algebra class is what this means is h of g of 45. And you want to start by writing the problem exactly that way, okay, because that'll help you reason out what the meaning of this problem is, okay? So what we're going to do is I'm telling you what these functions are, so I'm telling you basically what this is. G of 45, I'm telling you what g is. So if you look at my directions, g is the cosine, like that. So when we're doing g of 45, we're doing the cosine of 45. Okay, and one thing hopefully you learned in college algebra is when you do composition of functions, you do this part first. And then when you get the answer, what do? You plug it into h. So you're kind of moving this way when you do composition of functions. So you need to look at the triangle and figure that out. And then we're going to go to what h is, and h is 2x, like that. Okay, so let's take a look at what we have on this then. So if you look at the triangle down below here, let's see, that's 45-degree angle. The cosine is adjacent over hypotenuse, okay? So if you look at that, what's adjacent over hypotenuse in this diagram? 1 over square root of 2. Okay, so we got that, okay? All right, so we'll just write that as 1 over square root of 2. And then we can go ahead and we can rationalize that. You always want to kind of think about doing that. So I can multiply by square root of 2 over square root of 2. So I get 2 root 2 like that. So you kind of do the cosine just sort of at the side of your paper and get that value. Okay, now what you're going to have in the problem is you're going to have h of square root of 2 over 2. So what I'm doing is I found what g of 45 was, so I just replaced that like that. Okay, all right, everybody okay with that? Now what does my problem say h is? That's what? 2x. Okay, so what we're going to do if we do 2x is we just do this. Okay, you're just going to take 2, and then this thing right there is going to get plugged in like that. So you plug it into the function 2x. So what you're doing is you're taking the result of the cosine, and then you're plugging that into 2x. Does that make sense? Okay, kind of going this way, right to left. Okay, you should have worked a little bit with composition of functions in college algebra. So anyway, what you'd have is the 2's would cross out, so you'd have square root of 2 like that. Okay, that's a composition of functions. Okay, the next one, this is not a composition of functions. This is algebra of functions. So what it says is f plus g of 45. One thing that you typically learn in a pre-calculus class or college algebra is that this would be the same as f of 45 plus g of 45. Okay, that's a property that you have in algebra of functions. is you can just do those two things separately, okay? Now let's see, what's f? F is sine of x. So you get that from the direction. So what you're doing here is you're doing the sine of 45 degrees. You've got to look at the functions I gave you. What is g? G is the cosine of x. So you're going to have cosine of 45 like that. Okay? All right, does that look like something you've done before? Okay. Partially I'm using this to review. Now if you do the sine is opposite over hypotenuse, right? So the sine of 45 would be 1 over square root of 2. Okay, the cosine would be adjacent over hypotenuse. So the answers to both of those are 1 over square root of 2. Let me ask this, okay? Are you surprised that the sine of 45 is the same as the cosine of 45? Are you like, yeah, I know that? Okay. Remember, they're cofunctions, right? Sine, cosine, right? And what's the deal with 45 and 45? They're complementary. They add up to 90. Okay? So that's why that's coming out the way it does. Okay, so anyway, what you would have on this is this would be 1 over square root of 2. This would also be 1 over square root of 2. And then we're going to rationalize the denominator, and we're going to add the fractions because we're going to want to have a common denominator and everything. So I'm going to rationalize that. Then I'm going to rationalize this. Okay, and then what I'm going to have is this is going to give square root of 2 over 2. And then this is also going to give square root of 2 over 2 like that. Okay, now just add the fractions together. Well, the nice thing is you already have a common denominator. So when you put the fraction together, you'll just have a 2, right? Okay, a little background issue here. Okay, those radicals are alike, aren't they? Those are like terms. So you have 1 plus 1, or you have 2 radical 2. Okay, that's another algebra thing. It shows up a lot in trigonometry. Like if you had 3 radical 3 plus 4 radical 3, what's that? 7 radical 3. Okay, that'll show up. I just think of that as like terms. And then what happens is the 2's cross out, so you would get an answer of square root of 2 like that. Okay, that's the idea. Okay, everybody follow what I'm doing okay? Okay, now what I'm going to do with this one is composition. I'm going to kind of guide you through this a little bit and then see if you can finish this up. So what you're doing, anytime you're doing composition of functions, to me it's real important to write this way. P bracket g of pi over 4. Now pi over 4 is 45 degrees, so I'm going to go ahead and just do that like this. Now I'm going to kind of talk you through what you do on this and then give you a couple of minutes to finish this up. Basically, P of x is x over 2. Now that's a part of this problem. G of x is cosine of x. So g of x is equal to the cosine of x. And I got the triangle up there, so I'm going to see if you guys can figure this out. Okay, let me just sort of talk through what you do. Okay, if g of x is cosine, what are you going to do? You're going to do cosine of 45, right? Get the answer. Then what are you going to do with that? Where does it go? It goes into the p of x thing. So you start with this, because you always go right to left. So go ahead and see if you can finish that out. Get this part, get the answer, plug in the p and see what you get. Try it out. Okay? Okay, so what's the cosine of 45? 1 over square root of 2. Okay, cosine of 45 would be adjacent over hypotenuse. Okay, so if you get that, this thing's screwing up. This OneNote program's a great program, but it does crash some. And that's what it's doing. Okay, so that would be 1 over square root of 2. And then if you rationalize the denominator on that, you're going to get square root of 2 over 2, like that. Okay, so I'm going to put that in here like that. So you got to start by figuring out cosine of 45. Okay, now what do you do with that? Where does it go? Plugs into P. Now P is this. So what you're going to do is you're going to take this number, plug that in for x, so you'll have square root of 2 over 2 all over 2. Right? And then you got to simplify that. Sometimes students look at that and they don't know how to do this. What this really is it's a division problem. It's really that number divided by 2. So what do? Flip the second one. Remember, you divide fraction, you flip the second one and multiply. So you would have square root of 2 over 2 times 1/2. So what's the answer? Square root of 2 over 4. That's it. Okay? That's the idea, is kind of get comfortable with the composition and then at the same time get the trig function idea down. So that's what you got to do. Sometimes students got to review function stuff a little bit because it'll show up a little bit in this class. It shows up big time in calculus. Okay, so it's good to kind of get that in mind. Okay, so what I think I'm going to do next here, on this next page, I'm going to come back to 13 and do. I wanted to kind of do a couple of word problems. I will go back to 13 when I finish this up because it's arithmetic, but I want to kind of get you just started to finish up class tonight with the word problems where you actually start using trig a little bit, okay? So the first thing is you have to read the problem and you got to try to come up with a triangle, okay? That's the whole key, is come up with a triangle. So what this says is you have a radio tower is 200 feet tall. Then it says, how long should a wire be if it's to be attached 5 feet from the top and makes an angle of 45 degrees with the ground? The first thing is you got to know what I'm talking about by this. So we're going to try to just draw a diagram on this. So we're going to make a couple of assumptions. Okay, let's say that for all practical purposes, this is my radio tower. Okay, that's the little radio waves coming out like that. Okay, what our job is to figure out how long a wire's got to be. So you got a radio tower. And one thing it says about the radio tower is it does tell you that that is 200 feet tall. Okay, and what we're doing is we're looking for a triangle. At this stage in the class, we're looking for a right triangle. Okay, then it says you have a guy wire that is to be attached 5 feet from the top. So it's not at the top. It's going to be attached there somewhere. And then this distance right here is going to be 5 feet. And then the wire is just attached to the ground, kind of like that. Okay, do you see the right triangle? Okay, now you have to make an assumption that the tower is like at a 90-degree angle. You have to assume that, or you couldn't do the problem. So I'm just going to kind of pencil this in as that's a 90-degree angle, so that's my triangle right there. Okay, now what we're doing on this is it says this. It says that wire is attached 5 feet from the top. It also says that this angle is going to make a 24-degree angle with the ground. So it's saying the wire is making that angle with the ground. Okay, so we have that. Okay, and let's see. I think that's all we have on that is we have this. And now what you're going to do is you're going to find the length of the wire. So let's just call that x like that. Okay. Now, you have to use trigonometry to do this, okay? So the key thing is you got to kind of know which trig function to use. And when you're using a trig function on these kind of problems, do not waste your time on anything except a sine, cosine, and a tangent, okay? And I'm going to write down the definitions because we need to look at this a certain way. All right, so the first thing I want to just ask you is when you read the problem, does my diagram make sense to you? Does that look like what the problem's saying? Okay. Sometimes that's one of the more challenging parts of the problem, is figure that out. One thing they do on my math lab a lot on these problems is they give you a diagram. And I don't mind giving you a diagram because if you were a surveyor, you would know what you're measuring, right? It's not going to be a matter of interpreting somebody's English. Okay. So I want you to know that. So here's what we're going to do then. Let's look at this triangle. I'm just going to redraw the triangle of what matters. That's a 24-degree angle. That's x. Now you got to be kind of careful with one little detail of this problem. Okay, what is this? It's not 200. What is it? It's 195. Because remember, that thing was, the whole thing is 200, so that part right there is 5 less, so that's 195. That's what the problem says. That's a part of the problem. So that's going to be 195 feet like that. Okay? And that's what we need to focus on, is that triangle right there. Okay? All right. Now, we got to figure out which trig function we'd like to use. And just use one of these and keep it simple. So what you want to do is you want to focus on this angle and just talk it out. Okay, what are we comparing? If you look at 24, what do we call that? We call that the what? Opposite. What do you call that? Hypotenuse. Which trig function has to do with opposite and hypotenuse? Sine. So sine's what we're going to use. That's the simplest way. Another way would be to find this angle, but it's just kind of a waste of your time. It's unnecessary. You can find that angle because these two angles add up to 90, but you don't need to do anything like that. What you want to do is just do this. You have sine of 24 degrees is equal to the opposite, which is 195, over x. Now you have an equation that you can solve, and yeah, you're going to have to use your calculator to finish this kind of problem up then. Okay, so let's go ahead. This is a proportion. You can think of this as a proportion. One way you've learned how to solve proportions is to cross multiply, right? Okay, that's one way, so let's just do it that way. So if we do this and cross multiply, you would get x times the sine of 24 degrees is equal to 1 times 195, or 195. Now this is a mathematical equation, so what do you need to do to both sides so that the x is by itself? You need to get rid of that, so how do you do that? Divide by it, right? Okay, that's a number that's being multiplied by x. So what you want to do is, in your equation, you want to go ahead and divide both sides by sine of 24 degrees like that. Now you get your calculator out. Okay, and then we'll get, just kind of approximate, we'll round to, it says round to the nearest tenth of a foot. Okay, so we do that. So what you have to do now to finish the problem up is go to your calculator. You'd have to be in degree mode, so you always want to check that. And sometimes students forget about that and they get weird answers, so think about your answer. If I was in radians, your answer wouldn't make any sense whatsoever. So all we should have to do on this is just go 195 divided by sine of 24 like that, and then we'll round that off. So that's going to be about 479.4 feet. Okay, so what we just found is if in this diagram, that's going to be that length of the wire like that. Okay, now one of the things that trigonometry where it came from historically is people doing stuff like this, you know, and building things. And this goes back, you know, about 500 years ago. That's how we started figuring out how to find missing parts of a triangle. It's very practical. Okay, back in those days, for building things, it was very important to know how to do that. And the idea, what you'll find when you're doing these problems is, anytime you have a right triangle, you always know that's a 90-degree angle. Anytime you know two parts, you have to use trig to find the next part. Okay, so that's kind of what we're gonna be dealing with there. Does that problem make sense? Okay, so this is going to be, if you get to the end of this section, you start doing a little bit of the application. Okay, you start kind of seeing what we do with trig. It takes a while to get to that point because there's so much fundamental stuff you have to know. Okay, any questions about anything? Guys, is it time to go yet? Yeah, I asked students and they're like, yeah, okay, it's time. Okay, all right. So we'll just stop here tonight and then we'll pick up on this next time.